Hello and welcome to Gigaspace's live demo of Smart Digital Integration Hub, or DIH. In this demo, we'll show how to decouple digital services from systems of records, allowing for improved performance and lower complexity of the enterprise IT architecture. The starting point of the demo will be having systems of record, as you can see here at the bottom. On the top, we see client applications that need to access data stored in those systems of record. As we all know, accessing data directly is a complex and cumbersome task. To tackle this challenge, we've deployed the Gigaspace's platform. It's currently completely empty of any data, but in this demo, we will gradually integrate data sources into it, making it accessible via a simple unified data access API. We start by deploying plugins to the DIH, which load data from MongoDB and MySQL. MongoDB is a schema-less database, which in our demo contains customer data. MySQL, on the other hand, is a relational database, which in our demo contains account data. While data representation is different in these two databases, this difference does not impact the way that the Smart DIH works. Let's go ahead and deploy the two connectors. In the Gigaspace's Administration and Monitoring Center, we can see a space called Demo, which is currently completely empty. The space is the storage service where data is hosted in memory and distributed across different partitions and machines. For the sake of this demo, we have 4 different partitions with backups. These partitions can be deployed on different Kubernetes or OpenShift instances, as well as servers, VMs, or any other environment. As you can see, our connectors are now integrated with the systems of record. These connectors automatically perform the initial load of account and customer data. As you recall, customer data from MongoDB is stored in a semi-structured format. However, with the Gigaspace's Object Relational Hybrid Data Store, data is stored in a unified model, supporting both object, relational, and hybrid formats. The next step will be to connect the DIH to additional databases. DIH includes an embedded change data capture mechanism that integrates with many types of databases to reflect data changes without impacting database performance. In this demo, we show IBM's IIDR, which is an integral part of DIH that can integrate into any mainframe, DB2, IBM Z or I systems, as well as other popular databases such as Oracle, SQLserver, MySQL, or others. What we'll do next is deploy the Stream connector, which will allow us to listen to the database transaction log. The data in SQLserver contains a reference table with different loan types and rates. As you can see, we have multiple types of loans, including jumbo loans, conventional loans, and others. Typically, modifying this data or adding new data has to be done directly to the system of record using CQRS to prevent any data consistency gaps. The CDC mechanism ensures that the DIH is always in sync with the systems of record. Switching back to Gigaspaces, we can see that we now have the imported loans data. When examining jumbo loans, we see that the interest rate is 1.9%. However, as we know, interest rates have been on the rise, so let's assume for this demo that the organization has to update the interest rate to 5%. This change is conducted in the database directly via the core business applications. As you can see, the data is updated automatically and in real time on the Gigaspace's platform. The DIH Unified Data Model provides a single source of truth for any application or digital service querying this data. That's one of the core principles of this solution. Moving on, we now also want to connect the Kafka event stream to the DIH. As data from Kafka is ingested in the Gigaspace's ultra-fast distributed in-memory platform, we also want to trigger a compute function on this data. If we look at the Kafka queue, we'll see a bunch of messages containing account ID, amount, balance, etc. What we want to do is create an aggregation that sums data for each account ID and process it in real time within the DIH. It will then keep aggregating data in this pattern as we ingest more and more data. Instead of running a polling container that runs every 10 minutes or so, our embedded event-driven architecture enables us to execute this function on every data point that is ingested. We're now ready to start streaming the data into the DIH. Once we deploy the Gigaspace's streaming plugin, we'll see roughly 200,000 entries stream into the system almost instantly, with each data point triggering the aggregation service, as we can see here. These new data aggregation objects are being created in real time, and every account ID contains an up-to-date aggregated sum of transactions. By this point, we have integrated all our data sources and have all entries in the space. That's fantastic, but now to the million-dollar question: how do we access this data? We obviously want to avoid accessing the system of records directly because they have high latency. What makes things even more complicated is that different types of systems of record use a completely different querying syntax. To avoid this, Gigaspaces offers an internal microservices layer within the DIH that serves data to digital applications via a unified API. Alternatively, we can also query the data directory using SQL APIs. We see this in just a moment. Now, let's see how we can access the data directly using SQL APIs. The DIH contains a scalable data gateway using JDBC or ODBC drivers to enable access to the data for external applications. Here is the loans table. Although it might seem like we're accessing the source database, what we're actually accessing is the Gigaspace's in-memory unified platform. While the data is distributed across different partitions, from the developer's point of view, it seems as if it's all stored on a single table. Finally, we want to deploy a microservice within the DIH, which has direct access to the data, while exposing a standardized REST API to the business applications. Let's look into the Gigaspace's low-code generator that can easily create that data access service. We do this by creating a new service that fetches the transaction data which was replicated to the DIH from the databases. Let's name this service get-txn and deploy it on port number 8117. For the sake of time, we'll use a simple SQL query that I've prepared in advance and pasted in the text box. Before deploying, we'll run a sanity test to make sure that this new microservice works. Let's run this test on account number 192 that we know for a fact exists in the system. As you can see, all the tables associated with the query are automatically mapped to the new service that we've just created. In a minute, we'll see why this step is so important. As we hit the Send button, a microservice is generated behind the scenes. It's deployed and running on the Gigaspace's platform while exposing a REST API to the external world. This is really cool because without any development skills and without knowing a thing about REST functions or microservices deployment, we've easily built, deployed, and exposed a new microservice. It's that simple. Switching back to the Gigaspace's Ops Manager, we can see that everything here is presented as a service. The space itself, the plugins, the connectors, the service creator, everything is shown as a service. We can see that our new Get Transaction service is already up and running. The get-txn query logic is hidden from the business applications and is available via APIs. Our next test is to check if the deployed microservice really works. We test this using the REST API with the input parameter for account 192. And here it is. We retrieved all the relevant data from Gigaspaces using a RESTful call. Super easy and super simple. Switching back to the service dictionary, we can see the dependencies between tables and microservices and vice versa. So if we click By Service, we can see that get-txn is actually using two tables. This mapping is very important, especially if we need to update data, change tables, or change the service logic in the future. We can also sort by tables and see all the services that depend on each table. DIH also includes a holistic, real-time monitoring dashboard. Since the DIH stores mission-critical enterprise data, it's important to be able to monitor and track abnormal data consumption patterns and send alerts when such patterns are detected. We might also want to drill down onto specific object types and see how data is distributed across different partitions and services to keep fine-tuning the system once it's deployed. Before we finish, let's recap what we've seen in this demo. We deployed standard plugins and a change data capture connector. We integrated with Kafka and deployed an aggregation function. We've generated a microservice and exposed it via a REST API. We then deployed a data gateway for SQL interface and queried the space using an external tool. Most importantly, we've done all this in just minutes. Everything you saw in this demo was done in real time without any time lapses or video tricks. What else? Well, there's a lot more we can do with the GigaSpace's DIH. We can integrate with Active Directory, replicate data between clusters using our WAN gateway component, conduct hybrid deployments, or even multi-cloud deployments. We can send internal or external notifications, or even call other functions and create an event-driven workflow which is completely in memory. The sky really is the limit. Regardless of how your organization decides to use this solution, one thing is key. GigaSpaces provides a simpler, faster, and ultimately a more standardized way to create new high-performance digital services and reuse them across your organization. That's it for now. Thanks for watching.
To learn more, go to gigaspaces.com/contact us.